Hey guys, it's me. Just wanted to try something different. Not sure if this is going to work, but thought I'd give it a go. Let's do some math. Show you my face. Lucky us. Today we're doing 5.5, day 3, and we are covering examples 5 and 6. These are the half angle formulas, and if you haven't printed off the new half angle formula sheet I posted today, please do, because the tangent formulas I gave you are not as nice as the ones that you would have actually had when I sent you the formula sheet. I literally only looked at the double angles and saw they had half angles, so I have sent you guys a new updated formula sheet. Our goal is that we will be able to evaluate expressions and solve problems using the half angle formulas. So we're kind of going to do what you guys did Monday and Tuesday with the double angles as one lesson with half angles. So first we want to look at our formula sheet, but you might notice there's a lot of plus or minuses with all of them other than two of the tangent problems, which we do like. But so to determine the sign of the plus or minus formulas, look at quadrant the half angle will be in and pick. For example, if we were trying to find the half angle of 130, half of 130 would be 65. 65 is in quadrant 1 and everything's positive in quadrant 1. I really should have added a sine, cosine, or tangent, but it didn't matter. So anyway, we're going to go through 2 examples, and then I will give you a your turn to try. And for the your turn, I'm just going to reveal the answer and not walk through it because time is going to be of the essence today, I think. So, but I want to prepare you, so I want to give you as much as possible. We want to find cosine of 22.5. So the first thing you do is you figure out what angle is 22.5 half of. Oh, it's half of 45. So we'll write it as cosine of 45 over 2. And this will be on the unit circle, by the way. And so now we go to our cosine formula and we plug in. And we go plus or minus, and the cosine formula is it's the square root of 1 plus cosine of the actual angle, 45 degrees, all over 2. And then 22.5 is in the first quadrant. So cosine's positive in the first quadrant. So we'll change that to a plus, and actually we can drop it. But for now I'm showing you. And then cosine of 45 is 1 plus, it's root 2 over 2. All over 2. I normally don't like fractions, so I multiply by 2 over 2. And I get 2 plus root 2 all over 4. What's the square root of 4? Oh yeah, it's 2. So our final answer is 2 plus root 2 all over 2, and it's positive. So there's one example. I'll do a tangent one as well. And just to make sure I don't run out of room, I want to find out what is tangent of pi over 12. Now, when they're in radians and we're trying to figure out what the angle is, just multiply it, put a 2 on top to figure out what that angle is, and sure enough, it's pi over 6. So tangent is 1/2 of pi over 6. Now, I'm going to use the formula the 1 minus cosine of pi over 6 divided by sine of pi over 6. And I'm using that one because sine of pi over 6 is 1/2, and that will help me get rid of that fraction. And I also don't have to think about the sine of tangent because it was given. So this would be 1 minus root 3 over 2 all over 1/2. We flip and multiply, woo, woo, woo. And our final answer would be 2 minus the square root of 3. Yay? Okay, here is the your turn. I'm going to have you find sine of 112.5 degrees. And I lied, I'll go ahead and show you how I did it. So sine of 112.5, that'll be half of sine of, oh, I didn't even do this in a different colored pen. Sine of 250 degrees over 2. And so that's plus or minus, sine is 1 minus cosine, right? 1 minus cosine, oh my goodness, not 250, 225. 112 times 2 is 225. Woo! 250 is not even on the unit circle. Oh well, 1 minus cosine of 225 all over 2, which equals plus or minus 1 minus cosine of 225, that's negative root 2 over 2. So negative root 2 over 2 all over 2. I'll multiply by 2 over 2. Oh, and is sine of 112.5, 112 is in the first quadrant, so it'll be positive. I can get rid of that plus or minus, and it becomes 2 plus root 2 over 4, which is the square root of 2 plus the square root of 2 all over 2, which apparently is the same thing as cosine of 22.5. Okay. So that is evaluating, and now we're going to solve problems. And solving problems is a little bit, it's fun. But we'll do one example and one your turn of that. So it's a longer lesson today. Sorry. But it's the last new material of the day, of the week. Tomorrow will be review, and then Friday will be another quiz. Tomorrow there's flex time. And hopefully you made it, because I only had one show up earlier today and it was kind of sad, because I miss seeing you guys. So we're going to solve the problem sine squared of x over 2 equals cosine squared of x over 2 for x from 0 to 2 pi. Now you're like, why are they written squared? Well, because you'll notice all of these formulas have the square root plus or minus, and if they're written squared, we get rid of that without thinking too much. So I'm just going to replace sine of that with the formula. So the formula is plus or minus the square root, and I think it's 1 minus cosine of x all over 2, and this whole thing is squared, and that equals plus or minus the square root, and cosine is 1 plus, right? It's amazing what comes back. Cosine of x all over 2 squared. And now as these things are squared, it just literally turns into 1 minus cosine of x over 2 and 1 plus cosine of x over 2. And so now we want to solve for x. So I'm going to multiply the entire equation by 2. And we get 1 minus cosine x equals 1 plus cosine x. Set them equal to each other. Add cosine. I get 2 cosine x equals 0. So where does cosine of x equal 0? Oh. X is pi over 2 and 3 pi over 2. So not too bad. But it can be mathy, and there are more fractions. But normally we like to give it to you squared, which means take the formula, square it, and then simplify. I'm going to give you a your turn, and then we're done. So this isn't as bad as I thought. Woohoo! 2 cosine of, and we'll do theta over 2 this time, equals sine of theta. And theta goes from 0 to 2 pi. No real reason why I did theta. So give it a shot. And then come back and check your answers. And so this one, you'll notice they weren't given to us squared. So the first thing we need to do is I'm going to plug in, and I get 2 times plus or minus. So I'm going to replace the cosine of theta over 2 with the formula. So it's 2 times, which I can just do plus or minus 2, 1, cosine's plus, right? 1 plus cosine of theta all over 2 equals sine of theta. Shoot. I don't know what to do. I got the square roots, I got stuff, so I'm going to square both sides. And this becomes 4 times 1 plus cosine of theta over 2 equals sine squared theta. I can simplify this to be 2 plus 2 cosine of theta equals sine squared theta. Can I rewrite sine squared theta in terms of cosine? Oh, sure. Sine squared is the same thing as 1 minus cosine squared of theta. See, we're bringing everything together. I'm going to set this equal to 0, and I get cosine squared theta plus 2 cosine theta plus 1 equals 0. This simplifies to be cosine of theta plus 1 squared. I'll write it out, why not? Plus 1 equals 0. So cosine of theta equals -1, and theta equals -1 at pi. And then we squared, and remember when we square, we care, so we've got to check. Since there's only one answer, chances are good it's good. But so we plug into the original problem, and our check is 2 cosine of pi over 2. Does that equal sine of pi? Cosine of pi over 2 is 0. 2 times 0 is 0. Does that equal 0? The answer is yes. So our answer is theta equals pi. I understand this is mathy. I would encourage you to do the homework and the additional homework and come to Flex Times if you have questions. Miss you guys. Hope you have a great day. Hope to see you soon.